Ever since the inception of the first space telescope, one of the biggest endeavors astronomers over the world have undertaken is to find other potentially habitable planets in the universe. Many scientists believe humans must become multi-planetary species to ensure our survival. Latest reports suggest that we may have moved one step closer to this goal with the discovery of a habitable super-Earth found just 37 light-years away. Let's take a look at this amazing discovery. For centuries, planets beyond our solar system, called exoplanets, existed only in theory and science fiction. It seemed nearly impossible to detect planets light years away, since the relatively tiny worlds would appear billions of times fainter than their parent stars. But in the last 2 decades, astronomers have successfully developed indirect detection methods, most of which rely on measuring the effects of orbiting planets on far-off stars. In 1992, astronomers reported the first planet-sized masses around a dead star, the pulsar PSR 1257+12, which sits 2,000 light-years away. 3 years later came news of the first known exoplanet, a Jupiter-like gas giant orbiting its star closer than Mercury circles our Sun. That world was detected around the Sun-like star 51 Pegasi, a mere 50 light-years from Earth. The rate of exoplanet discovery has since climbed rapidly, thanks to the development of 3 main detection techniques, which all involve both ground and space-based observatories. Over the last decade, the tally of confirmed alien worlds skyrocketed to just over 720. However, the hunt is still on for a truly Earth-like planet, one with the right size, temperature, and composition to host liquid water and maybe life. The most successful planet hunting technique to date has been radial velocity, also called the Doppler wobble, with more than 400 new found planets to its credit. Astronomers using this method look for a star's wobble, telltale shifts in a star's light spectrum caused by the gravitational tugs of orbiting planets. The more massive a planet and the tighter its orbit, the greater its effect on the host star. As a result, the majority of discoveries made with this method have been so-called hot Jupiters, because of their large masses and close proximity to their parent stars. Nearly 24 planets have been detected using the microlensing technique, starting with the 2003 discovery of a gas giant twice the size of Jupiter, orbiting a star 18,000 light-years away. Gravitational microlensing occurs when one star passes directly in front of a background star, as seen from Earth. The gravitational field of the foreground star acts like a lens, magnifying the light of the background star. If the lens star has an orbiting planet, the extra mass amplifies the magnification in a telltale way. The transit method, another popular technique, looks for periodic dips in a star's brightness as an orbiting planet passes in front of, or transits its star, as seen from Earth. By measuring the amount and frequency of a star's dimming, astronomers can estimate the orbits and masses of its planets. Additionally, researchers can calculate a planet's surface temperature from the world's orbital period and its star's temperature. Since its launch in 2009, NASA's Kepler mission has used the transit method to confirm more than 60 new exoplanets and to identify 2,300 candidate planets, now awaiting confirmation via further observations. Monitoring more than 150,000 stars, the planet-hunting spacecraft is the first that's capable of detecting Earth-sized worlds in a Sun-like star's habitable zone, the region around a star where liquid water, and maybe life, can exist. Throughout its mission, Kepler has uncovered more than 17 stars with multiple planets, as well as a new class of planets that orbit double and even triple stars. But only a handful of the exoplanets discovered so far are terrestrial, rocky types like Earth, and very few are in their stars' habitable zones. For instance, 3 of the smallest rocky exoplanets yet detected, each no larger than Mars, closely orbit the red dwarf star, KOI 961, and are far too hot to host life. Calculations based on initial data from Kepler suggest that 100 billion planets exist in the Milky Way galaxy. Of those, as many as 10 billion may be rocky planets like Earth. Future searches with improved monitoring technology are expected to reveal ever smaller exoplanets, worlds that orbit at larger distances from their parent stars, and even alien moons. Based on the progress made so far, some experts think we'll find the first truly Earth-like planets in the next year or two. By combining information from radial velocity and transit methods, for instance, astronomers will be able to determine the compositions of an Earth-sized planet's atmosphere and search for telltale signs of life, such as oxygen and methane gases. It's kind of amazing to realize that in the past couple of decades, we have confirmed detections of over 4,000 exoplanets, or planets orbiting other stars. This is but a tiny fraction of the estimated trillion exoplanets roaming the Milky Way galaxy, but it's still way better than we had in the 20th century. As soon as astronomers started finding exoplanets, they realized what a wonderful zoo we live in. Planets orbiting dead remnants of stars. Planets bigger than Jupiter orbiting closer to their star than Mercury does the Sun. Planets so hot that they rain lead. Purple planets. And the super-Earths. Rocky planets slightly larger than the Earth, orbiting within the habitable zones of their parent stars, the place where liquid water can potentially exist on a planetary surface, and where life like our own has the best shot of surviving. First, we have to be clear about what we mean by habitable, as some wild worlds in our solar system stretch far beyond what we would consider normal. After all, no other known planet is quite like Earth. The other small rocky planets in our solar system are either barren wastelands or nightmarish hellholes. The gas giants, with their deep crushing atmospheres, are ruled out. That means that, in our survey of super-Earths, we need to find planets that look and act a lot like our planet. This includes sitting within the habitable zone of a star to make sure the temperatures are just right, as well as having atmospheres that are relatively thick but not too thick. These planets also need to have liquid water on the surface, not locked beneath a frozen crust or boiled away into a vapor. And lastly, they must have a magnetic field to protect that atmosphere and liquid water from the constant brutal onslaught of the solar wind. There are a lot more criteria that need to be in place for a world to host life. But without these base conditions, the chances of something growing in an alien world are pretty slim. Astronomers generally define a super-Earth as any planet between the size of Earth and 10 times more massive. Astronomers tend to call planets larger than that mini Neptunes, but that clean distinction disguises a lot of nuances that are important for determining habitability. Something closer to the size of Earth has a better chance of being habitable because presumably it's very similar to Earth. And something closer to the size of Neptune probably would not be a very fun place for life to find a foothold because Neptune in general isn't all that hospitable. As planets go up in mass, a rocky core gets better and better at hanging onto a thick, gassy atmosphere because of its enhanced gravity. Eventually, there will be so much atmosphere that the planet would be better characterized as a gas giant than a rocky world. Unfortunately, we lack a clear dividing line between those two extremes, and super-Earths bridge that gap. This is where the orbit matters too. If a planet is too close to its parent star, regardless of its size, it's just going to get roasted. Ultimately, a habitable super-Earth needs to have the right density, indicating that it's not too rocky or too gassy. Even then, it's only a guess, as astronomers have scant information about any particular exoplanet. As for the magnetic field of any exoplanet, this is a matter of pure speculation. Scientists think planets larger than Earth are likely to host strong magnetic fields, but it's impossible to know for sure. For example, while Venus and Earth are roughly the same sizes, only Earth has a substantial magnetic field. The latest reports state that astronomers have discovered a super-Earth orbiting a red dwarf star just 37 years from our solar system. The exoplanet Ross 508b skims the so-called habitable zone of its parent star, the area in which surface temperatures are suitable to allow for the existence of liquid water, a key ingredient of life. The newly discovered exoplanet has about 4 times the mass of Earth and was discovered using a new infrared monitoring technique. The proximity of this super-Earth to our planet means it is ripe for atmospheric investigation, which could help researchers determine whether life could exist around low-mass stars. Red dwarfs like Ross 508, which has about 1/5 of the mass of the Sun, are small stars that account for around 3/4 of all stars in our galaxy, the Milky Way. These stars are especially abundant in the region around our solar system, making red dwarf stars and their systems ideal targets for the search for planets outside the solar system and the investigation of possible life elsewhere in the universe. The fact that red dwarfs are small means that they are cool. with temperatures of between 2,000 and 3,500 Kelvin. Their relatively low temperatures make them dim in visible light, unlike larger stars, and means astronomers must study them in infrared. To do this, the Astrobiology Center in Japan developed an infrared observational instrument called the Infrared Doppler Instrument to mount on the Subaru telescope in Hawaii. With this instrument, the world's first high-precision infrared spectrograph for an 8-meter class telescope, the astronomers set about searching for signs of planets around red dwarf stars. Specifically, the researchers looked for the telltale wobble that an exoplanet causes in the orbit of its parent star. The wobble registers as a tiny shift in the wavelength of light from the star as it moves toward and away from Earth. The discovery of Ross 508b marks the first success for the project, which is officially named the IRD Subaru Strategic Program. Ross 508b, just the third planet to be found around such a low-mass star, has an average distance from its parent star of just 1/20th times the distance between Earth and the Sun. The astronomers who discovered it believe that the planet's highly elliptical orbit carries it into Ross 508's habitable zone every 11 days. Astronomers have stated that the planet is the first successful detection of a super-Earth using only near-infrared spectroscopy. Before this, in the detection of low-mass planets such as super-Earths, near-infrared observations alone were not accurate enough, and verification by high-precision line-of-sight velocity measurements in visible light was necessary. While this discovery is exciting and the planet will be studied for years to come, astronomers hope that the new method will help them find even better candidates for a habitable planet in the future. If you found this video informative, you may also like this one, which talks about a big discovery made by NASA in the Martian atmosphere. If you had the chance, would you leave your life on Earth behind and travel to a new planet? Please share your thoughts in the comments section below.